When it comes to triangles, we have several different ways of categorizing them. One way is by the angles they have, another way is by the lengths of their sides and how they relate to each other. So we're talking about angles, okay? If you have all, that's a little bit too much. If all of the angle measures are less than 90 degrees, then you have an acute triangle. If you have an angle measure, just one, that's the most that you can have, that is a right angle, then you have a right triangle. And if you have a triangle with an obtuse angle, then of course this is going to be an obtuse triangle. You can only ever have one right angle or one obtuse angle. You can't have more than one, because think about it. A right angle is 90 degrees. If you had a second right angle, you would already have 180 degrees, but the sum of all the measures of the angles of a triangle is 180. Same thing for obtuse. You can't have more than one. But you can have three acute angles because they are all less than 90. Now when it comes to the side lengths, here is what we have. Okay, you could have that all side lengths are the same. So that means that this side length is the same as that, which is the same as that. And if that is the case, then what you have is what's called an equilateral triangle. Okay, cool enough. And then you have something like this, where they aren't all the same, but you have exactly two sides that are the same. And the third side is going to be something different. If this is the case, this is called an isosceles triangle. A lot of neat properties kind of come out from that, but we'll get to that later. And then you could have this situation, where this side length is different from that one, which is different from that one. Like no two side lengths are the same. And this kind of triangle is called a scalene triangle. So when I mention these words, if you have an acute triangle or right or obtuse, you need to have in your mind a picture of these diagrams. You need to know what it means to be an equilateral or an isosceles or a scalene triangle. Now, when we start to compare triangles, there are two types of comparisons that we have. We have triangles that are similar versus triangles that are congruent. So for both of these, corresponding angles are congruent. So it's going to be for both. So it's going to be true for triangles that are similar and triangles that are congruent. So when we talk about triangles that are similar, they've got the same shape, but the size is different. So it's like if you take an image and you pinch to zoom or you zoom in or out, the image just gets bigger, but the proportions stay the same. They don't get wonky. So if I have, for example, if I take this big angle like this, right? It has a certain measure. Even if I were to do this, if I were to cut back on how long these rays are drawn, the angle measure didn't change, right? So the angle is still going to be the same as long as you keep things in proportion. Now, when it comes to side lengths, that's where there's a big difference between things that are similar versus congruent. Congruent triangles are basically you copying and pasting. It's the exact same thing, right? Nothing changes at all. The angle measures are the same, and the corresponding side lengths are the same. So, corresponding sides are congruent in congruent triangles and corresponding sides are proportional in similar triangles. That means if one triangle is twice as big as the triangle that's similar to, everything, all the side lengths are doubled, but the angle measures are not doubled, right? Because again, whether you have this or it extends really far out, the angle measure is still going to be the same. So in the next video, we're going to just do a few examples so you can see the difference between when they're congruent versus being similar, and then how we can take that into some application problems.